So building students' mental math skills really builds their math fluency. This is a skill we want them to get. Um, yes, you'll have a calculator. You can do that. You've got a phone, so you've got a calculator anywhere you go. You can figure out, sums and differences between numbers that way. But it really helps if you have some mental math skills so that you don't have to type in 2 + 2 into a calculator, just to get those simple things so that you can, faster than a calculator, estimate and get some good ideas on putting things together or finding sums and differences. So some approaches to mental math. When we're talking about addition specifically, use expanded forms. That's a really good way to do it. So like splitting up your numbers. So like instead of 125, I could think of that as 120 and 5, right? So that's a good way to do it. Then use your commutative and associative properties. So like, put your hundreds together, put your tens together, put your ones together. So like kind of start with that, and then you can use some other strategies. So then you can underestimate, round down, and then add it back later, or you can overestimate, meaning round up and then subtract it off later. So those are good skills to have. And mental math is not something that you're going to teach once to elementary students and then move on. And that's kind of how we do other math topics, like, oh, I'm going to teach you how to add with 3-digit numbers, and then we're going to move on. We're going to do subtraction. We're going to do 4-digit numbers. We're not going to come back to that. Mental math, you're going to keep coming back to it because every time we do a different topic, we want to talk about the mental math strategies for that. So like when we do addition with 3-digit numbers, we want to do some mental math strategies for addition with 3-digit numbers. When we move on to subtraction, we want to do some mental math strategies for subtraction. When we do 4-digit numbers, we want to do mental math for 4-digit numbers. So it keeps coming up and we keep needing to practice and emphasize this for students. So there are many ways to solve these problems. So realize that a way that you think of it or that you do it might be different than the mental math steps that your student is using. So you can use and your student can use whatever method you want, so long as it leads you to do the math in your head without using any rote processes like regrouping or exchanging. So you should not have to write anything down in order to do these problems, or if you do, very, very little. So like we want to be able to do them mentally. That being said, as a teacher who is going to try and explain and show mental math to students, it is important that you can actually write your thinking down. So even though we're doing the problems in our head, how can we write this down in a way that students can see what it is? They have something to look at that would explain the process that's going on in our heads. So let's look at several examples of this. So we have 768 plus 53. So I think this would be a good example of like the underestimate and overestimate, right? So like 768 plus 53, that's not easy to do in my head, but I could find numbers that they're close to. So like, for example, 770, that's close, right? 768 is close to 770. 53, that's close to 50, right? Now, if I'm going to write this down, I want to be careful that I don't write that that's equal to 770 plus 50, because those two things are not equal, right? But this is kind of the process I'm doing in my head. So let me talk through this in my head and then I'll write it down. So 768 is close to 770, 53 is close to 50. I'm going to add those together because that's easier to do in my head. So 770 plus 50 would be 820, right? So, but that's not my answer because I overestimated with the 770 and I underestimated with the 50, right? So 760 plus 50 is 820, but then I added 2 more than I needed when I did 770, and I added 3 less than I needed when I did the 53. So if I've got 820, then I need to actually do like 2 less than that, but then 3 more than that, right? So that would be really the same thing as just 1 more, and that gives me 821. So if you're like me and you're visual, then just hearing that is really hard, right? Even though I'm doing it mentally, just hearing it and not having anything to look at is hard to follow. So let's write that. So what we were really doing is we're saying, okay, 770 is easier to add, but really 768 is 770 minus 2, right? And then 50 is easier to add, but really 53 is 50 plus 3. So this is doing some expansion. And I'm listing this for your benefit, and I think it's good, like for your notes to list this, but you don't necessarily need to always like say what properties or what you did. If it helps you to follow, then you can do that. And so then the idea is to not do it in that order, right? So let's use the commutative property. And say, well, it's easier to do 770 plus 50 and then deal with the minus 2 and the plus 3. And notice when I'm moving that around that the minus sign is going with the 2 when I move it. So then 770 plus 50, we said that that was 820, and that was the part that was easier to do in our head. But then negative 2 plus 3, or if you haven't done negatives yet, then you change it to 3 minus 2. And that's just fine, right? So like if we were going over by 2 here and under by 3 here, then I would go and say, well, over by 2 means I now need to subtract 2. Under by 3 means I now need to add 3. That's the same thing as just adding 1. And so we end up getting 821. So if we look at the next example, I can think of a few ways that I would do this. What I would tend to do, and again, I'm going to talk through it first and then write it. What I would tend to do is say, well, 401, that's close to 400. 99, that's close to 100. That's really easy to subtract, right? 400 minus 100, that's 300, right? The question is, how do I adjust that? And that gets a little tricky with subtraction, right? So if I do 400 minus 100 to get 300, well, I was supposed to start with more than 400, right? So that means that whatever answer I'm getting, it should be one more, right? It should be one more because I had 401, not 400. And then I subtracted one less, right? So I subtracted 100, but I was only supposed to subtract 99. So I actually subtracted one more than I should have. So that means it's another one I'm going to add. So 401 minus 99 would be 302. Now that's confusing to a lot of people because you're like, wait a second, 99 is less than 100, so wouldn't that mean that you subtract it? No, because you already subtracted it, right? So I'll write this so you can see what we're talking about. So we're saying that 401, we're thinking of that as 400 plus 1. And then 99, we're thinking of that as 100 plus 1, right? So this is just some expansion and rewriting. So that's what we're doing here, right? We're really subtracting 100 and then we're adding 1, right? Because that's because we need to make up for the one that we subtracted, right? So if I'm subtracting 1 more than I wanted to, then I need to add it back in. And then use the commutative property again. So we could say 400 minus 100 is easier to do, and then add my ones together. So this ends up being 300 plus 2, which is 302. So again, to explain like why is it that I'm adding this 1, right? Why is it that I'm adding 1 there instead of subtracting 1? Because if we're subtracting 100 instead of 99, that means we're subtracting more than we should have, right? So if we're subtracting more than we should have, we need to add it back in. There's other ways you could do that. So you might think of other ways. One way that I don't know that I would go to right away personally, I think is actually really clever, would be to, instead of using 400 and 100 and change both numbers. Let's just change one of the numbers. So like another idea, and I'll make a note of it here. I won't necessarily show all the steps. Another idea would be we could rewrite 401 as 2 plus 399. Then that's really easy, right? Then say 399 minus 99, right? So instead of using 401, use 399. Well, 399 minus 99 is 300, and then you just need to put the 2 back in, right? So then add back the 2. And you'll be amazed. Your students will come up with different methods you never thought of, and you'll have to think through them and be like, does that make sense? And yeah, there's lots of ways we could approach these. Let's do one more. 85 plus 156, or I'm sorry, 84 plus 156. So lots of ways we could do this. One thing I might do is just maybe like split it up, do some expansion. Maybe like split up the 80 from the 4. That's maybe like using the make 10 actually, right? So if I've thought of it that way, we're going to think of the 84 as 80 plus 4. And then let's use the associative property. So I'm not actually changing the order, but just saying, well, that's easier because of the make 10 strategy. 4 plus 156, right? 4 and 6 together make 10. So this would be 160, and then that's a lot easier to add to 80. So we could do that in our head. Again, I'm showing the process written down, but the idea is, let me just take the 4 from this 84, put it with the 156 using the make 10 strategy. That's going to give me 160, and then 160 plus 80 is again easier to do in my head. That just gives me 240. So how you think through it versus how you show it is a different thing. Some other ideas. One idea I had was to put the 6 over, right? It's kind of the same idea. So instead of putting the 4 over here with the 156, what if we put the 6 over here with the 84, right? So we could say 84 plus 6, and then that would leave 150 left over. So we just split up, we did the same thing, we just expanded this, and then it's the same from there. 84 plus 6, that's easy to do, right? So do that in your head because of the making 10 strategy. So that would be 90, and then 90 plus 150, you still get the same answer. You get 240. Another idea, you could split them both up, right? So instead of like putting the 6 with the 84 or putting the 4 with the 156, you could just split it up entirely. So we could say, okay, how about 80 and 150 and 4 and 6, right? So technically that's using our commutative property, but it's the same idea. So then 80 plus 150, that's not bad to do. We know that that's 230. 4 plus 6 is 10. And so then we get the same answer again, 240.